this video we're going to look at the use of mathematical induction for the proofs of propositions. Let Pn be a mathematical statement which is conditional on some index n. For example, the proposition that 3 to the power n minus 1 is an even number. We can show that this proposition is true for all values of n greater than some initial value, say n equals 1, using the following procedure. First of all, we show that the proposition is true for the initial value, p1 is true. Secondly, we show that if Pn is true, then this necessarily implies that Pn plus 1 must also be true. If these conditions are satisfied, then Pn is true for all values of n, whatever value we choose. This is the process of mathematical induction. As an example, we're going to look at the proposition that the product of n odd natural numbers is always itself an odd number. So to do this, we want to prove that the product of ai from I equals 1 to n is odd if each of the individual ai's are odd. So how do we go about doing that? Well, the first stage is we prove that's true for the value n equals 1. Well, that's trivial. P1 equals A1, and that's odd by assumption. Now the second stage is going to be a little bit more complicated. We need to show that Pn, where Pn is the product from I equals 1 to n of ai, where all the ai, remember, are odd. If that's odd, then this necessarily implies that Pn plus 1, which is equal to the product from I equals 1 to n plus 1 of ai, is itself odd. Now this isn't as tricky as it looks. All we need to do is first of all note that we can write Pn plus 1 is equal to Pn multiplied by an plus 1. Now we've assumed Pn is odd, so we can write Pn equals k plus 1, where we're going to assume k is an even integer, and an plus 1 is equal to g plus 1, where g is an even integer, so k and g are both even. And then we can write Pn plus 1 is equal to the product of k plus 1 multiplied by g plus 1. Now if we expand that, we can write that as kg plus k plus g plus 1. Now kg and k plus g are both even numbers by assumption, so if we take the sum of them and add 1, we get an odd number. So Pn plus 1 is necessarily odd, which proves by mathematical induction our initial proposition, that the product of n odd numbers is always itself odd.